So, hi everybody, welcome to today's session of Working in Sustainable Tech, where we are going to be covering satellite technology. When I was looking up and kind of researching to do the intro to today's session, I found out that there are, and I hope my research is right on this, over 11,000 individual satellites orbiting the Earth as of, I think the last count on that was around June of this year, which is a big increase. I think they said that's an almost just under 40% increase in 18 months. So yeah, huge. And hundreds of miles above the Earth's surface, all these 11,000 satellites, this vast network is continually collecting data about our planet's climate system and providing measurements almost in real time of the temperature of our oceans, the land, the atmosphere, and helping us not just keep a tab on global warming and climate change, but also having some really interesting and unique applications in how we fight climate change in myriad ways, which is what we will be discussing, exploring, and learning more about today. So we've got two brilliant speakers who have come to join us, Mark from Magdrive and Fran from TradeSpace. So with no further ado, Mark, would you like to come and talk to us about Magdrive, about what you're building, about the team, and about the people that help you bring this to life?
Sure. I will caveat, I had prepared a more sort of sustainability focused overview of Magdrive, but very happy to discuss that in the breakout space as well.
Absolutely.
So yeah, my name is Mark Stokes. I'm co-founder and CEO of Magdrive. We're developing high-power electric plasma thrusters for satellites in low Earth orbit, deep space, and beyond. I want to start by giving a background into sort of the state of propulsion within the space industry, the state of sustainability in the industry, and really focus on the main challenges where Magdrive is applying itself, but really affects the much wider area of sustainability, which in turn encompasses all the different areas that anyone interested in the area could work in. It's very clear, I want to make it very clear, it's not just a space for engineers working in space. So yeah, I was actually going to start my point just as you had, Cherry, with sort of a view into the future of just how many satellites. We had about 1,000 satellites as a species in space in 2010, about 9,000 satellites at the start of 2023, and we're looking at an unbelievably huge increase to 60,000 by 2030. This comes with a lot of opportunity for commercial satellites, commercial companies, for monitoring climate change, for providing internet across the planet, especially to important remote communities where access to the internet, medical assistance, everything is very limited, but it also comes with a lot of challenges, which we're going to get into as well. So sustainability in space, I had to dig around online, and the phrase that kept popping up was ensuring that all humanity can continue to use outer space for peaceful purposes and socio-economic benefit now and in the long term. That sounds really nice. It sounds very nice, and it sounds very fluffy. It sounds too nice, and it's too fluffy, frankly, because there are massive challenges ahead of us. And it's especially important to focus on that socio-economic benefit, which is a really important part tied to all the technology we're building. That technology begins with propulsion and getting things into space in the first place. This is a chemical rocket. This is the kind of thing you'd find on the bottom of a SpaceX Falcon 9 or any of its competitor companies like ULA or anything like that. And what it does is it uses a combustion engine, the kind of one you'd find in a car, and it just fires a lot of power out the back of it in a very familiar format. What this does is it gives you a huge amount of thrust, which is literally just measured in newtons, but it's miles per gallon, if you like, or its specific impulse, as we call it in the industry, is very low, which is a measure of its efficiency. On the other hand, within the industry, you have electric propulsion, which is the complete opposite. In this case, you have excellent miles per gallon, and the reason is that it's spitting out individual ions at a time, which is great for longevity. As you can imagine, however, you get very little thrust out of this. Whereas even the smallest chemical thruster would achieve tens of newtons of thrust, a huge electric system like this one would probably do about 100 millinewtons. And it's massive, it's huge, and it weighs the size of a bedroom flat. So why Magdrive? I got to do a quick plug for Magdrive, of course. What we're building is a high power electric plasma thruster, which achieves that high 100 millinewtons of thrust per kilogram, but in a much smaller mass and a very small format, so that we can achieve, constellation management in low Earth orbit, so that we can start doing orbital assembly, orbital manufacturing, and really push up the next chain of what humanity is capable of doing in space. But onto the real meat of why we're here. We mentioned the huge increase in the number of satellites. So this is the case about 2010. This is from the European Space Agency's Time to Act initiative. And what you see here are, alongside the 5,000 satellites, you can see what is just space junk and orbital debris. There's a handy key down there in the bottom left to scare the shit out of you about how much there is up there. And to give you an idea of the destructive potential of what's up there and the challenge this poses, a single chunk of aluminium traveling at 7 kilometers a second, very usual speed, impacts with the equivalent of about 2 pounds of TNT, which is enough to blow the doors off a mid-sized family car and scatter the remains all over an area the size of your house. Those pieces go on to travel at similar or greater velocities, and they will impact other satellites as well, which is why every time someone launches an anti-satellite missile, everyone loses their minds, because it affects everybody completely. All that junk is eventually going to spread out, and it's going to become a very uniform, in the worst case scenario, prison around the Earth, where we will never launch anything into space ever again, not even a satellite to help with internet connectivity. So one of the biggest areas we want to apply Magdrive, and where a lot of attention is being paid in the current industry, is in mitigating this, either by active debris removal opportunities or by sending up something with that capability already built in. And that's something we want to do with the Magdrive. With its very high thrust, the high efficiency combination lets us do avoidance maneuvers. Instead of only having to do them, twice a year, we can do them weekly, which is what it's going to be by 2030. There has been a shift in the industry towards this, sustainability mindset very much, and a big shift towards green propulsion, as they call it. This gentleman here on the right, he's looking at a massive vat of anhydrous hydrazine, which is rocket fuel. It is one of the most horrendously chemically, environmentally destructive chemicals mankind has ever created. It is a neurotoxin. You will die if you breathe it. If you smell it, actually you can't smell it. That's the insidious thing about it. You can't smell it. It doesn't have a smell. If you get on your skin, if you ingest it, if you look at it funny, you will die. It's an excellent rocket fuel though, so the space industry loves it. But they're trying to move away. And what they're coming up with is a few alternatives to hydrazine. Because as Aerospace America points out, it's carcinogenic amongst all of its other horrendous properties for the environment and people handling it. What it points out, though, for example, is that a great opportunity for an alternative would be hydroxyl ammonium nitrate as a fuel oxidizer, which is correct. You can transport it in bottles instead of really dense metal. People on the ground don't have to fuel it, looking like something out of Black Mesa. The problem with it is it still has exactly the same qualities as hydrazine for the environment in its manufacture. It's still a really nasty, toxic chemical. And it's about as green as current propulsion gets. The reason we can't sort of get past this is because we need that extremely high thrust option. Now, this is an area where a lot of materials scientists work, a lot of chemistry and biology comes into it as well, and is a real sticking point for the industry, especially because what we need this for is getting things into orbit in the first place on massive launch vehicles. Moving on to something a little brighter, one of the areas in particular that I want to draw more attention to is the idea of just how advanced the ambitions are in space around sustainability. So in the UK, we have Space Solar Limited, which span out of the Space Energy Initiative of the Satellite Applications Catapult. It's a lot of words containing space, a lot of phrases containing space words, I realize, but it's called Space Solar Limited, and its ambition is to build a 3-kilometer long solar array in space and beam the power back down to Earth. It's actually feasible. They've worked out all of the economics of it, the engineering of it, and their intention is to not build one, but build dozens of them to power the entire country's needs, and to do so from space. The difficulty with this is that it's going to be a huge structure, and you can't launch all of that with one rocket. So when you're up there, you have to start moving pieces together, and you need propulsion systems for that, which have a high thrust to actually match velocities, but then have a high efficiency to go and find new targets and keep bringing those pieces together. But it's the start of what is really being called orbital manufacturing and orbital assembly, where we'll be able to not just do this for our energy needs, but where we want to actually start using this for resource extraction on asteroids, where we want to manufacture in space better medical equipment, better fiber optic cable, things we can return to Earth, but also things where we can use the resources in space for a very cyclical, closed-loop space economy. So if you hear anyone talking about a space economy, that's exactly what they mean. Using the materials that exist in space for use in space, and eventually, yes, to move people out to space, to live, and to expand, and to grow. Which leads us into the final point, which I want to really bring attention to, which is it's very important who owns what. Moving humanity out into space, for example, has been quoted as, creating a second point of failure. Going to Mars, for example. A second point of failure, if anyone studies statistics, a 100% increase on one is not very good. So instead, we'd be much better off building my favorite space architectural structure, an orbital habitat, looking exactly like what's on the left there, and growing it out to use asteroids, which we can mine, full of aluminium, full of iron, which are perfect building materials for space. Space itself is a perfect place to build. Microgravity relieves a lot of the tension, a lot of the stresses that you find with regular industrial and mechanical engineering. The difficulty, of course, is in manufacturing gravity, which either you need a shitload of mass for, such as the Earth, or you can induce it through centrifugal force, which is why all of these space structures look like rings, because they're going to have to spin. The problem, and the reason this is called who owns what, is because a single point of failure is fine in terms of maximizing where humanity lives in space, but it's not okay in terms of who controls everything. Now, this is the case for governments and new countries coming into the space age. Arguably, the US and China have a massive head start on this, and they're in prime position to reap all the major benefits of a new space age. Smaller countries are having to really specialize in what they do. They're going to have to get really good at a particular part of robotics or space medicine, leverage what they already have as strengths and apply it to space, because it's true. You can be a space chef. You can be a space exercise physiologist. The list is endless. But to maximize those socioeconomic benefits, not only do we need to be able to give those benefits back down to as many nations and groups on Earth as we can, we also need a real spread in space of who controls what and who owns what. Having everything owned by, Blue Origin, it's probably not going to be great for pushing humanity out and doing as much as we can with it. What I'm essentially advocating for is more groups controlling their own space stations with their own interests, which doesn't give us just a single point of failure in terms of where we live and its technology, but also a single point of failure in terms of what form of politics and social organization is going to work best in space. We have absolutely no idea. We're moving from a place which is a 2D plane into a 3D plane. The fact that the Earth is a sphere is kind of irrelevant because everything is determined by grid, lines on a 2D map. In space, everything is three-dimensional, which completely changes our relationship with our environment, as well as how fragile everything is, how interdependent and how interreliable we're going to have to be on each other in space, as well as on the next group, just over there, who are building and developing something else. It's a big question with no open-ended answer, but it includes legal questions, economists, it includes sociologists, it includes basically every aspect that you could possibly imagine on Earth and applying it to space. So something which is really important to point out, apart from just having that engineer focus. So that is me. I've got no sense of how much time I've spent on this, but that is me for now. And I will see you all for question time. Thank you very much.
That's fantastic, Mark. Thank you so much. And for somebody that watched Armageddon in their formative years and was very, very frightened of what might fall to Earth, that thing about the space junk has really terrified me. So there we go. I'll be asking you more about that in the Q&A. Thank you so much, Mark. Really appreciate that. And now, Fran from Trade Space, come and share with us what you're working on, what your company's building, and what people and skills you need to drive that forward as well.
There we go. Are you able to see the screen?
Perfect. Thank you.
So just so I can see what I'm looking at. So hi everyone, my name is Francesca Smith. I work for a company called Trading Space as a geospatial analyst. I thought, seeing as this is all about working in sustainable technology, I would start a bit with a bit about me and kind of my journey into SpaceTech. So my background is as a geographer. I have a degree in geography and a master's in GIS and mapping. I've always had a keen interest in the environment and in forests, and I ended up working in the forestry sector. And in that role, I kept coming across satellite imagery as a customer, and as it allowed us to monitor at scale. And I just thought that satellite data was such a great resource and a really powerful tool that could be used for more than what I was using it for. You know, for example, to monitor sustainability. And I wanted to make it my full job rather than a small part. So I started to look at job postings, see what skills I was missing. And for me, it was coding. I'm sure there are people with all sorts of backgrounds here. So I want to say there are lots of roles in space tech that don't involve coding, but I would say, you know, if you want to work with satellite imagery or like data directly, coding is quite a key skill. So I learned to code a combination of, you know, self-teaching and kind of using grant funding for courses. And as a result of that, I felt confident enough to start applying for roles, and that led me to work for Trading Space. So in terms of Trading Space and how it came to be, it was founded in 2019 by Robin Sampson, who has really extensive experience in the satellite sector. And he saw the opportunity to use satellite data to kind of facilitate direct trade between agriculture producers and consumers. And also, I guess, like the value, like that recognition of the value that distributed ledger technology and satellite monitoring of agriculture could bring to each other. And we did that really successfully. You can see here that we were able to complete the first space traded coffee from Colombia to Glasgow, which led to raising sort of like funding and back into kind of develop our services even further. Today, our mission is to like enable agricultural supply chains to be more sustainable, ethical, profitable, and auditable using the most innovative space and distributed ledger technologies. I guess in day-to-day, this is primarily as working with partners in like the coffee and cacao, so like the chocolate sectors, to bring traceability into their supply chains. So here's Trading Space in numbers. I think this really highlights the scale that satellite data kind of allows you to monitor at. You know, 250,000 farms, 128 billion square kilometres surveyed across 18 countries. But, you know, still with quite a lot of detail there. We monitor, you know, these farms at, you know, as individuals level, as well as like the collective supply chains. And a lot of the data we use like the resolution to just meters, so we can really offer that detail too. Our main product is deforestation monitoring, and you can see we've detected over like 3.1 million hectares of deforestation. Our clients are often like sustainability teams, and they really like this, as you know, it kind of helps them focus their efforts, you know, to particular areas of their supply chain once they've identified those kind of like more problem areas. And that in turn allows them to kind of improve the sustainable practices across their business. So I thought I'd give you kind of like an overview of what we do to monitor deforestation, and then hopefully that kind of give you an idea of like the different skills and like processes that I need to, you know, do something like this. So we start off with using like satellite imagery and machine learning to detect deforestation. You know, here we're kind of using research skills. You know, we're making sure we're using like reliable, innovative data sources, you know, data engineering. You know, this is a big data, you know, a lot of data comes off satellites, so kind of knowledge of cloud computing and databases, and then machine learning to evaluate it to our requirements. Next, we take that kind of process deforestation data and the location of a farm that our client provided, and we assess if a farm's compliant to legislation such as like the EU deforestation standards, or maybe even like their own corporate sustainability strategies. And then we write that result to a blockchain ledger or a barcode output, and we call this like a sustainability passport. And this can be used to share the results of the analysis in like an auditable way, like a secure way. We find that the sustainability passport ensures that buyers and consumers are really informed of like the origins of their product, and like ensures transparency, and that's something really important to us. But being a startup, innovation is important to us, and this is where we work on a lot of other projects too, in ESA, Innovate UK, etc. So here are some examples of the kind of other projects we're working on at the moment. So looking at carbon stored in agroforestry farms, frost damage on coffee crops. We're also looking at crop health in other crops like maize, so like disease. This week actually we've just launched our mobile app onto Google Play, and this helps companies like collect data, and we're finding a lot of our clients, this is the first time they're collecting like geospatial data, or they're digitizing a lot of the data on paper, so that's a kind of a tool to help them do that. And we're also looking at traceability, so we call it from bean to cup, so that you would be able to see the exact field that your bag of coffee in your cupboard was grown from. And this is our team. There are 8 of us. We're split into sort of like a tech and a business side. Got really kind of like wide range of skills and backgrounds. I've included a list of skills on the side here that I can consider useful for like our area of SpaceTech, but this is definitely not exhaustive. And actually one of the best bits of working in a startup is you get to kind of learn a wide variety of things. Like, well, it's one of my favorite things anyway. And I guess that being said, in terms of like skills we're kind of be looking for in the future, it would be kind of that full stack developer kind of role. And speaking of the future, this is a really nice time of the year to talk about this, actually, December coming up into the new year. But what we'll be doing is just kind of continuing our mission, so next year we're going to be attending quite a lot of events. We'll be launching our sustainability passport like commercially. Our hope is kind of for every farmer to be able to retain access to markets through kind of trustworthy and transparent reporting techniques. There's new data opportunities too. New satellites are being launched. We are particularly excited about biomass. So big challenges like climate change, we want to consider like how we can continue to help farmers sort of like mitigate the risk. And also advances in AI, you hear about AI all the time now, ChatGPT, and kind of what role that has in the space sector. Definitely kind of been looking into that as well. Yeah, so thanks for listening. Hopefully some of you encouraged to have a look at the space tech industry for your next role. I'm quite biased, but it is a really exciting place to be. And yeah, happy to answer any questions in the breakout room.
Amazing. Thank you so much, Fran, for sharing that. And I liked how intentional you were about that move that you made in your career as well, and the fact that it was something that, like you said, you went and looked at job adverts, looked at what skills were needed, realised where the gaps were, and went away and intentionally upskilled in those areas to make the move. So yeah, I think I like that. And sounds like what you're building has got such a wide range of applications that can help on a climate front, but also on a social impact front as well for the farmers.